and welcome to the first of our live panel discussions today here at Apex. The topic is the future of electronics manufacturing. Now, the plethora of new applications and technologies that are in development are driving manufacturers to use increased levels of integration across heterogeneous technologies. Many of these challenges and opportunities are offered by complex integrated systems, and were highlighted in a recent joint white paper between IPC and iNEMI. I'm joined today by some of the people who contributed to that paper to discuss some of the issues it raises. To my extreme left, we have Frank Mullany from iNEMI. Welcome, Frank.
Glad to be here.
Yeah. Next to him, we have Ravi Parthasarathy from Zestron.
Thank you. Good to be here.
Thank you for coming in. And joining us remotely today, we have Dan Gamota from Jabil.
Great to see you, Trevor. And I'm glad that we're on this journey together.
All right, so let's get straight off with my very first question, which is that complexity and integration have been long-running historical themes within electronics manufacturing. So what's different about complex integrated systems today?
Well, there's two major shifts going on at the moment. The first one is around the huge variety of functionality and the types of technologies we're trying to integrate into an ultra-small form factor. We're now talking photonics, electronics, sensors, we're talking about the thermal management, the structures, MEMS. So that is a much broader mix of functionality into the same small package. The second big transition that's happening is that we're seeing a blurring in the distinction between advanced packaging and PCB. Yeah. So with concepts like direct attach, like advanced substrates, that line is beginning to disappear. So we're really coming into a new ball game there in terms of a big step forward in the amount of integration we're seeing and the level of complexity around that.
Right, okay. Ravi, I mean, how do you want to add to that? Because, I mean, you came in as a commentator on the finished article, but you ended up actually contributing to it.
Yes, and in addition to what Frank already said, sustainability is a key part of this complex integration system. We are looking at life cycle analysis, which was one of the key areas that we wanted to also look at, was not only like as we are developing this kind of packages and putting together the stacked packages into a single architecture, how do we ensure that it meets all the requirements from the environmental standpoint was something that was also some thought process put into it.
Right.
And at the same time, we also wanted to focus was on the economic considerations. It has to be cost effective, then it has to meet high performance requirements like Frank mentioned about analog, digital, optical, mechanical components going into the same substrate. How do they interact with each other and at the same time maintain that high performance at a low cost? So those were some of the things that was and that's how complexity and integration has been a part of this industry, but this is something unique that it was thought about, like it gives an overall view of where this industry is going in and what are some of the challenges and gaps that one has to consider.
Right. No, you're absolutely right. I mean, sustainability is becoming a hugely important area. Dan, you're right at the rock face, being obviously a manufacturer of these systems. So what is your view on this work? I mean, are you seeing at Jabil, for example, introducing more clean rooms into some of these EMS facilities? How are you approaching it?
Great lead-in. I concur with everything that Ravi and Francis have said. And I'll go back to the comment that I made earlier, that this has been a journey. You may remember when we said smart manufacturing in the building blocks, and we talked about a digital thread. And we observed the fact that we started seeing this blurring between the back end of line for foundries. We saw that semiconductor assembly, packaging, and test, the capabilities that are provided there. And then we also saw the third level, the electronics assembly. And so in the backdrop, we've seen that these equipment sets are not relegated to a particular vertical. And what we are seeing today is really the products that are enabled because now these different capabilities, as Ravi mentioned, where the clean rooms now, you see more integration. And so to me, really what we see today is the final products. We see the products that there are growing revenue streams, large expanding markets. You see, you look at any of the analysts, as you know, silicon photonics for high performance computing, high speed communications is driving a large amount of development. We're seeing the autonomous systems, such as advanced driver assistance systems that are requiring high precision placement of different components. We see that the value chain, there are options. Companies are interested in expanding margins, and so they're moving up. And by moving up the value chain, they're able to start increasing their margins. We also see the customers seeking more resilient supply chains. Every time you move from one facility to another, there's a potential for disruption, there's a potential for loss. So, and then the fourth one really is the outsourcing model. We're starting to see that not historically, but early on, as semiconductor and IDMs were developing technologies and products, they took on the heavy lifting of manufacturing. But now that the adoption by the customers are growing, these IDMs are outsourcing. So we're starting to see outsourcing 2.0. So really, it's the outsourcing 2.0. We're seeing growth in the markets. We're seeing customers requiring more resilient supply chains, and just evolution of EMSs like ourselves wanting to have greater margins moving up the value chain. So it is kind of a great time to be in electronics, and it's really, as you said at the very beginning, it's aligned with the core of miniaturization, integration, and automation.
Absolutely. I mean, would you concur with that, Frank? I mean, literally the number of different applications, the way electronics is growing in so many different applications with so many different challenges, from high-speed communications to lots of different areas, electric vehicles, etc. The number of applications is increasing the complexity as well.
Absolutely. This is application driven, 100%, right? Because it's requiring heavy investments by players in terms of their capabilities across a broad mix of technologies. That's not easy to pull off. And the reason why we're doing that is because we have a series of highly demanding applications running right across multiple society needs. So whether you're looking at autonomous driving to try and improve car safety, whether you're looking at AR, VR for the next generation of interaction between humans, whether you're looking at advanced sensors and actuators in micromechanical systems for medical applications. These are all addressing real human needs. So that's really what's driving this whole thing. It's not being done on a whim.
Right.
And just to add to that, I would also say, as these demands are increasing, and there is going to be an increased demand for it, one thing that is still a big gap is the metrology tools to address those kind of demands and to get to those type of packaging level and to meet those requirements. So that is something that is still a big gap, and there is a lot of technology and a lot of R&D effort that still needs to go into to see how those metrological equipments and tools and programs, software, those could be improved upon to meet those kind of requirements.
Right. So Ravi, I mean, what sort of ecosystem changes do you anticipate we're going to need as a result of the increased focus on CIS?
In terms of ecosystem, one thing that there are a couple of things. One would be a big investment from R&D, research and development. that needs to look into what are the requirements. As from a cleaning company, cleaning supplier, I can talk about our R&D. Like they are looking into what type of cleaning performance is needed for this type of components to ensure they are functioning properly and it's not having any reliability concerns. And then it should also there needs to be a good collaboration between industry organizations and like iNEMI and IPC, who have a lot of stakeholders, and they all need to put together and come up with a plan, come up with a guideline to see how they could develop a process that would benefit the industry.
Okay, thank you for that. So moving back to Dan, I mean, what sort of ecosystem changes do you think you're going to be making at Jabil to, accommodate some of these this increased focus on complex integrated systems?
I don't see major changes. I see more leaning into some of the things that Ravi and Francis mentioned. There's definitely a greater focus on collaboration. You're seeing that we're in a once in a lifetime situation. There are definitely the accelerants and the investments and the commitments being made by all the different countries around chips and advanced packaging, that you're in a situation where you're going to see a significant amount of innovation. I think with that, you need to also be very disciplined in how do you take that innovation into scalable manufacturing. And so for me, what I believe is that you're going to see a renewed interest in collaboration. You have already had it in IPC and iNEMI, but I think that you're going to find that other organizations are going to be much more collaborative in terms of helping to establish best practices, helping to establish guidelines. I think standards also will become important. Digital transformation, I think that, Ravi mentioned earlier sustainability. I think digital data is going to be important. I think you're going to have building blocks and foundational elements that are going to pull the entire industry up. We're all going to, we're going to rise, so to speak, in terms of our ability to communicate across barriers. We're going to be sharing data. Equipment sets will be, connected. I think that you will see, in some regards, consolidation, but I think the consolidation will be done to make sure that customers ultimately have the least friction in terms of their supply chain. So I think collaboration is going to be an accelerant. I think you're going to see truly frictionless data transfer across all the different dimensions of the ecosystem. And the third one is, I believe there will be consolidation as appropriate, but I think ultimately the customers are going to be driving the consolidation requirements based on their risk tolerance in terms of product launches.
Right. Well, there's quite a lot in that. So basically back to you, Frank. I mean, what do you see as being the big roadblocks for the industry? What do they need to address to try and bring some more structure into some of these systems?
Well, Dan's actually already touched on one of the critical issues for the ecosystem, namely that we need to be able to transfer easily data up and down the supply chain and across a multiplicity of suppliers. And that's driven by the huge number of technologies we're trying to integrate into a single solution. So that ability to be able to do it seamlessly will make a huge difference, particularly when we're looking at a high mix manufacturing environment, right? Where you're getting churn as you reconfigure your assembly line, reconfigure your manufacturing process in the input components. So you're going to have to be able to easily communicate data about not just the basic specs of the components, but the performance and what you expect from reliability, et cetera, et cetera. Right. So that's issue number one. That's around smart manufacturing. The other big one, which is going to be more addressed by individual companies, is we're driving folks to deeper technology capabilities, more clean room environments, smaller form factors, finer adjustments in the mechanical placement of devices. So at an individual company level, the investments there are going to have to increase on the R&D side. The third one, though, which is an interesting one, is the challenge around environmental sustainability. These, when you deal with an integrated component in a small form factor, what do you do with it at the end of life? How do you extract out the key critical materials in there, either from a toxicology point of view or from a sheer value recovery standpoint?
Yes.
So we have a lot of work to do from a sustainability standpoint for these hugely complex systems.
Absolutely. No, I couldn't agree more. Do you have a view on what some of the roadblocks are?
I totally agree with what Frank said. Two things that I would also bring in is as we have this diverse technologies like the analog, digital, optical, silicon photonics, as we are integrating all of this into a single architecture, component traceability and data security is another thing that is really critical on how do we ensure that there is a secured package and we don't have any counterfeits or any risk of losing that data. So that is something that is also needs to be addressed. And Frank already touched upon the sustainability. That is really a big topic right now in a lot of OSATs and IDMs as we communicate with them, because they want to have a resource management. They want to minimize the amount of it's not only about the resource management, but they are also very much concerned about emissions. They are also concerned about what is wastewater, waste generation. Right. So they want to minimize all those things which are also part of their ESG initiatives. So those are some of the things that as a Zestron, as we communicate, like all this comes into as part of this CIS and under the umbrella of sustainability.
Right. I mean, Frank, looking at the industry trend towards using chiplets in these advanced packages, do you think that's helping to bring in some, homogeneous sort of what's the word? That's helping to make life a little bit easier for managing all these different challenges within packaged devices?
Certainly the work that has been done in the chiplet space over the last 10 years, I would regard that as the initial steps in this whole trend that we're looking at, right? That was the first big transition away from a single wafer inside a single package to a multiple wafer scenario with different technologies. So the work that has been done there is what we will build on as an industry, but extending that beyond just the OSATs and the IDMs, all the way now up into the folks the EMSs, PCB manufacturing, board assembly, and we're going to be extending that train of thought, that methodology, right up the whole way. Right. And that's the trend we're looking at as a result.
Okay. So what do you think the role of government should be in this?
So governments have an interesting challenge on this one. And the challenge is it's going to be very hard for a single country or a single region to capture the entire supply chain. I would say it's going to be a really hard challenge. And you're dealing with a much broader mix of companies. So a government really needs to think very strategically about the strengths of the industries it has and how to build on that and expand on that and help them to play key roles in this marketplace. It's not simply a question of approaching one or two companies and getting one or two major investments in this scale. It's more about actually nurturing an entire ecosystem and covering parts of that supply chain.
Right.
Big challenge for them.
It's a huge challenge for them. And, Dan, if I can come back to you, because you've got facilities in different parts of the world. A lot of countries are now looking at electronics as almost a strategic must-have, in their, portfolio. But, what do you think are the big should be the role of government in helping to make this happen?
Well, they're already actively involved in a great setup for me. Last week in Washington, D.C., as you know, the CHIPS Act has been having different workshops. IPC, iNEMI, and representatives across the ecosystem are all in attendance. Um, you know, their biggest thing is workforce. Uh, new talent that's coming into the workforce is going to be an enabler. The students and young talent or first time talent into the electronics manufacturing, they'll have capabilities that are somewhat unique. They'll understand how to do things in the virtual environment. They'll be able to model. Data will be more accessible. They'll be able to do digital twins of the product, of the manufacturing line, as well as the end product in the field. And so I think you're going to find that government has the ability to help and provide that training environment for new talent coming in. You will also have the government to provide training to the veterans of the manufacturing world, because the veterans today, all that information is locked up. It's tribal. They have it in their brains. That information has to be somehow taken from individuals and shared across platforms. And that's where the ability to establish this data, the sharing of data that was mentioned. So I think workforce. Then the second one is the data sharing. I think that both Ravi and Francis mentioned big issues around data. How do you share it? What's the visibility, traceability, the provenance, the security, and then ultimately the liability? If you share data and your data is not good, what is the liability? The third one was mentioned already about best practices. How do you foster pre-competitive activities? You want to see best practices around, as Francis mentioned, design. Ravi mentioned materials, processes, testing. The fourth one, and we're already seeing it with the government, they really want to strengthen the supply chains. They don't want to necessarily disrupt supply chains, but they want to strengthen supply chains. And then the last one is establishing facilities. We're hearing about, similar to the Fraunhofer Institutes, providing facilities that enable companies to vet out ideas and to be able to go from a medium technology readiness level, moving up to a 7 or 8 that allows scalable manufacturing. So those are the four. I would say this pre-competitive environment, strengthen the supply chain, the data, and then the workforce.
Do you think the governments have a full understanding of the entire all the components they need to have an end-to-end supply chain? No.
That's why people like Francis, Ravi, and I, and everybody in the audience needs to participate, because we are all in this game together. And that I think that what's happened is over the past few years, people have become more appreciative of how complex supply chains are. I think now we're seeing a drill down into people understanding the complexity associated with electronics. But I still think that we're in electronics complexity supply chain 101. I think that people really need to upskill their appreciation. And it's only through activities and events like Apex and other events where people begin to appreciate how complex it is. But there's definitely a long education that needs to be provided to the folks making decisions, financial decisions.
Right, this is a long road that we're on, but what essential technologies do we need to put in place to help make this happen?
Well, we've mentioned a couple of them already in terms of the communication networks that need to happen for smart manufacturing, in terms of miniaturization, in terms of what we need to see happen to create circular economies for sustainability. But I'll flag up one other one, which is one to watch in this space over the next 10 years, and that's additive manufacturing,
Right.
particularly around high mix, low volume product mix sets that require very high performance in a small package. Be very interesting to see what emerges there over the next 10 years on that one.
Right. Absolutely. Well, we know there are some companies already doing that, but it's a very complex area altogether. Do you have any views on what technologies we need to develop to make this happen?
In terms of technologies, right now there is a lot of work been going into the 5G and ADAS. Like right now, there is still like we are realistically speaking, we are in level 2, somewhere between level 2 and 3, and there is always talk of going into level 5. So there is, as we get into this kind of technologies, it becomes like we are one of the things that's becoming more prominent from the packaging world is people are moving away from flux and they are getting into hybrid bonding. Hybrid bonding is a key technology enabler when it comes to meeting some of those requirements, but it brings its own issues, like how do we ensure with the CMP process we get a planar surface, how do we ensure there are no particles left behind. So those are still some of the areas which there is no answer to right now, but there are already companies that are working in that field to come up with a solution. But those things are, again, like as Dan mentioned, like there has been an industry consensus right now that this technology is coming, it's going to stay here. But how do we ensure that we are ready not only right now but even 10 years down the line?
Right.
Because technology keeps on changing.
Yeah.
So that is something which is really critical, and that's why we need all the stakeholders who are part of the IPC, iNEMI, and they are already contributing to it. But it's kind of fragmented because what we see at IPC typically is people are just, IPC at Apex traditionally has always been more about the surface mount, but now that they are slowly learning into advanced packaging,
Yeah.
and as they are getting into this advanced packaging, like there are new things that's coming up every day. So there is a lot of new challenges, and how do we make sure that all these people are in the same room so that we are not repeating the stuff, whereas everyone can move in the same direction.
Yeah, we need the guidelines and standards to help us move that direction. Dan, I'm going to give the last question to you because Ravi mentioned earlier on that obviously sustainability is a big part of all this. As a manufacturer, I mean, companies are fairly easily managing to deal with the Scope 1 and Scope 2 emissions policies, but Scope 3 is going to be quite a challenge for you to try and implement. Is that something that's on your radar at all?
It is on our radar. We have individuals, we have a group that is actively involved in that. And remember, we're a manufacturer, but we also are a services provider. And so our customers are coming to us asking questions. It is early in the process, but we are participating. IPC, as you know, has an activity, conversations at iNEMI, SEMI. So really, it's the entire ecosystem is involved. It's a journey for all of us. And I don't think any one organization has an answer. I think collectively we have ideas of how to proceed forward. And I think what we need to do is make sure that we are taking into account all the stakeholders' requirements, because this is a large undertaking and it's only going to be addressed appropriately if everybody has a say in it. Everything that was mentioned in terms of the different technologies that we're looking at, we're making sure that technologies that are being established and developed address everything that is important on sustainability. And so we already have integrated a lot of the design considerations and other types of considerations that impact all the requirements being outlined by all the things for sustainability. But it's not, I don't have a magic wand that's going to make things happen today. I think it's all of us working together collectively are going to be successful.
Great. Well, gentlemen, I think we've had a great debate around the topic today. We've certainly highlighted a lot of the issues with it. And not sure we've come up with too many of the answers yet, but we've certainly highlighted a lot of the issues. And I would certainly recommend to our viewers out there, if you do get the time, to download that CIS white paper that iNEMI and IPC put together. I think will you get it on the iNEMI website, Frank?
It's both you can get at it from both the iNEMI and the IPC website. And there's also links embedded there for providing feedback. We would like to hear what the industry thinks of some of our thinking here on this one.
Absolutely. So there you go. So thank you very much to Frank Delaney, to Ravi from Zestron, and of course to Dan Gamota. And thank you for watching today.